In this video, I'll be showing how to graph the solution set to a compound inequality. I have a couple of examples of that, but before we get to those examples, first we have to learn what a compound inequality actually is. It's just when you have two or more inequalities that are basically crammed together, smashed together, or joined together with the word and or with the word or. And to help us understand these a little bit better, I'm going to look at two examples. The first one is going to be our and inequality. In this inequality, we have 5 is less than x is less than or equal to 12. That's how it would be read. Again, going back to a compound inequality, it's two inequalities. So we have to find those two inequalities. There's one right here. Now I like to read that backwards, as I say, in other words, from right to left. But if I write it the way we would read it, it would say x is greater than 5. And our other inequality that we have in here is right here. This one says x is less than or equal to 12. And like I said earlier, this is an and inequality. And the reason it's an and inequality is because we have to find numbers that satisfy this inequality and they have to satisfy that inequality. Now, to graph it, we're just going to simply graph one inequality at a time. I'm going to start with x is greater than 5. So I go to 5, I put the open dot on it because we're not going to include the number 5, and then I want all the numbers greater than 5. Those are all the numbers to the right. Then I go to my second one, x is less than or equal to 12. Since we want to include the number 12, we fill in our dot this time, and now we want all those numbers that are less than or equal to 12. But like I said, since we have this compound inequality and it's an and inequality, we want to find numbers that will satisfy the red inequality and numbers that satisfy the green. Well, those are going to be all the numbers that are in what I'll refer to as the double shaded region. Because if I take a number like 7, 7 is greater than 5, and 7 is less than or equal to 12. And all of those other numbers that are in that double shaded region are our compound inequality solutions. So when I graph it all, I'm really just looking at these solutions here in the double shaded region. These solutions that are out here, that's not a solution, nor are these. You know, for example, if I take the number 13, is 13 a solution to both? Well, I come here and I go, is 13 a solution to this one? Yes, 13 is greater than 5. But when I look here, 13 is not less than or equal to 12. Therefore, 13 is not a part of our solution set. And that's why the solution is just the double shaded region right here. So when you are done with your final graph, that's all you should see. You'd take this part off and you'd take this part off as well. Now I have two other parts to this. I said express the solution set builder notation. Well, set builder notation just says we want to have these fancy little parentheses. So x such that x, or x such that, and now we just write our compound inequality. 5 is less than x is less than or equal to 12. There it is in set builder notation. Now there's another type of notation that we can use referred to as interval notation. Now in interval notation, we use what will kind of look like a point, but it's going to look like this. We're going to put our small number to the left, and it's a 5. We're going to put a comma, and then we're going to put our large number to the right, 12. Now, this is going to be a bracket here, though. So here's the reason that on this side, this side we have the normal parenthesis, and on the right side we have the bracket. This one, this parenthesis here, is because the x is less than 5. We don't include the number 5. But on this side, the bracket is telling us to include the number 12. So in interval notation, we have our small number to the left, our big number to the right, and then either parenthesis or a bracket. On our second example here, now we're going to look at an or inequality. Now a couple little reminders here. The word or means either. The word or also means union. In other words, the union of two things, or sometimes it could be 3 or 4. But the ones we're going to look at, we're going to have a union of two things. Now, union, sometimes we use that little symbol to represent the union of two things, or a lot of times we can kind of basically put, we can put an or where we see the union symbol. So this one, graph the solution set of x is less than -1 or x is greater than or equal to 3. I don't have to break apart the inequality here. We can clearly see that we have two inequalities, one here and one here. So I just start and I graph x is less than -1. Go to -1. Now I have all of these numbers to the left because I want the ones that are less than -1. Then I have to go here and I have to graph all the ones that are greater than or equal to 3. So equal to 3 is right there, shaded in, and then I want all the numbers to the right. I have just graphed the solution set to this compound inequality. Now I said let's write it into set builder notation. So in set builder notation, remember we'll go to our fancy little parenthesis here. Our variable was x, such that, and now we just write down our two inequalities. X is less than -1. We can write the word or x is greater than or equal to 3 and close it off. And we have it right there. Now sometimes, like I said, we could use this symbol, union, which really just means or. But we have the union, so it's basically telling us we have two solutions. We have or two sets of solutions. We have all of these, but then we also have to include all of those. And that's what our set builder notation is saying. Now I also said, write it into interval notation. This is going to look a little different than the interval notation from the previous one, because again, we're always going to start with the smaller number. So I come up here to my graph and I go, well, what's the smallest solution in that part of the graph? Well, that would go on and on forever to the left. In other words, the numbers keep getting more and more negative until you get to -infinity. Now, since you can never get to -infinity, we're going to go with the parenthesis. And then, now you go to the bigger number. Well, that's going to be -1. And since we're not including -1, parenthesis again. Then we're going to include the word or. Now we have to do the solutions to the right side. Well, here we're including the number 3, so bracket, comma, and then all the way to the end, all the way to an infinity. And close it off. And again, our little word or here in the middle of this one, that we could change, or we could replace with the union symbol. Either one would be acceptable. And that's going to conclude my video on graphing compound inequalities.